Assalamualaikum and hi. So today, my friends and I will be presenting about our assignments for advanced electrical circuit. So let me introduce me and my friends. So my name is Rosha Shahira and my friends are Nur Maisara, Fazla Husna, Nur Izzah Idina and also Melo Shahira. So we will be presenting about function transform and also bot plot. Okay, so I will explain about our introduction. So our introduction have two parts, which is about the transfer function and also the bot plot. So what is a transfer function? It is a convenient way to represent a linear time invariant system in terms of its input-output relationship. It is obtained by applying a Laplace transform to the differential equation describing system dynamics, which will be assuming 0 as initial condition. So which is the transfer function is actually the ratio of Laplace transform of output to the Laplace transform of input. And then the second one is for the bot plot. In electrical engineering and control theory, a bot plot is actually a graph of the frequency response of a system. So it is usually a combination of a bot magnitude plot, which will be expressing the magnitude, usually in decibels, of the frequency response, and a bot phase plot will be expressing the phase shape, which in simpler terms, a bot plot is like a map showing how a system responds to different frequency of input signals.
So next, I will explain for question C. This question is giving 5 times j omega plus 2 divided by j omega times j omega plus 10. For this question, we need to multiply with the same value as the question, which is we multiply with j times 5 times j omega plus 2 divided by j omega times j omega plus 10. After that, we will get the answer is 5 times 2 times j omega over 2 plus 1 divided by j omega times 10 times j omega divided by 10 plus 1. After that, we get 10. And then after we get the same value with the tak cukup masa. After we multiply the value same with the question, we will get the answer is 5 times 2 times j omega over 2 plus 1 divided by j omega times 10 times j omega over 10 plus 1. By that, we will get the answer of the denominator and numerator is the same, which is 10. So we will we will cut the 10, and then the answer we will get the h omega is j omega divided by 2 plus 1 divided by j omega times j omega over 10 plus 1. After we get the answer of HDB, we will draw a graph of HDB, which is for the y-axis is HDB and for the x-axis is omega. As we know that j omega is 20 log 10 j omega, and the 20 log 10 j omega will be intercept at at x-axis. And as we know that the line start at 20 and the line is decreasing at 1, and then the line will straight until 10, and at 10 omega the line will be decreased as the value is 20, and then the line will be straight line until 10 omega because of the tan inverse omega divided by 10. And after that, the line will be decreasing until 100, and then it will be static until when. So that's all. Thank you. as we get the answer of HDB, we will draw a graph HDB, which is y-axis will be y-axis will be HDB and x-axis will be omega. And as we know that that j omega will 20 log j omega will intercept at 1 omega, and then as we can see that the graph is start at 20 and then it will intercept at 1, and then after that it will straight line until 10 omega, and it will decreasing until 100 because it's 20 log 10 j omega divided by 10 plus 1.
So here's the given dot plot. We observe 3 distinct regions: an initial rise at positive 20 dB, a flat region, and a decline at negative 20 dB. Here, first step, we will identify the initial zero at origin. The initial rise at positive 20 dB indicates a zero at the origin. Mathematically, this is represented as j omega. So next, we see the plot flatten out after the initial rise. This behavior indicates a pole at omega 10. So the transfer function now becomes j omega over 10 plus 1 in bracket negative 1. Then we adding the second pole at omega 15. The final region shows a decline at negative 20 dB. So this indicates another pole at omega equal to 50. Including this, the transfer function now becomes j omega over 50 plus 1 in bracket negative 1. So the final transfer function, we have a 0 at the origin and pole at omega 10 and omega 50. So the final form is h omega equal to j omega over 10 plus 1 in bracket j omega over 50 plus 1 in bracket. So to conclude, we systematically derive the transfer function by analyzing the dot plot. Each part of the plot guided us to identify zero and poles. This method ensures a clear and accurate determination of the system transfer function.
Hi guys, I'm Sarah and I will continue with the discussion part. For the first part, in this analysis, we use dot plots to demonstrate how the systems gain and phase shift as the frequency changes, which is crucial for designing and understanding control systems. And for the second part, the dot plots shows that our systems gain increases until 10 radians per second and remain constant until 50 radians per second. And lastly, it will decreases due to a zero at the origin and poles at 10 and 50 radians per second. That's all for me, and I will pass to the next person.
So I would like to conclude what we have done for our assessment. In conclusion, transfer functions and dot plots are valuable tools in the analysis and design of systems across numerous disciplines, for electrical engineering to control theory and beyond. Transfer functions provide a concise mathematical representation of how a system processes input signals to produce output signals. By understanding the transfer function, engineers and scientists can predict and manipulate the behavior of complex systems, allowing for the design of efficient and reliable systems. On the other hand, dot plots offer a graphical representation of a system frequency response, displaying how the magnitude and phase of the output signal vary with input frequency. They provide valuable insights into a system stability, frequency characteristic, and transit response, aiding in system analysis, design, and optimization. So together, transfer function and dot plots serve as indispensable tools for engineers and scientists, enabling them to model, analyze and optimize systems across a wide range of applications, ultimately leading to the development of innovative technologies and solutions. So that's all from us. Thank you.